explaining about state transition matrix and its properties. State transition matrix, an important part of both zero input response as well as zero state response represented in state space. While finding the solution of state equation, this is the most important factor, state transition matrix. State transition matrix in the Laplace domain, it is defined as phi of s equal to Si minus A inverse, where I is the identity matrix, A is a system matrix. The state transition matrix, it is represented in time domain, that is the inverse of Laplace transform of phi of s. That is nothing but phi of t, that is equal to Laplace inverse of Si minus A inverse, that is equal to e power at. That is called state transition matrix. Because the matrix it is also matrix because transition is carried out by matrix exponential. That's why it is called state transition matrix. It has some properties. The important properties are phi of 0. Already we know that phi of t equal to e power at, that is equal to Laplace inverse of Si minus A inverse, right? First we will take only this one, e power at. So phi of 0, t equal to 0, what you will get? E power 0. E power 0 is nothing but what? Actually it is 1, but it is a matrix, right? That's why it is an identity matrix. So this one, phi of 0 equal to e power A into 0, that is identity matrix. Second one, phi of inverse, you can say phi of power, phi power minus 1 of t equal to phi of minus t. How it is? Just see. You know already phi of t equal to e power at. Phi power minus 1 of t. Just substitute e power at whole power minus 1. You know it is like x power y power n, right? So same way x power m power n. So e power minus at, right? E power minus at is nothing but what? Phi of minus t. Okay. Third property is phi power k of t equal to phi of kt. It is similar to second one only. Just phi power k of t, e power at whole power k. It is equal to e power a kt or k into at, right? That is equal to what? Instead of this, it is a phi of kt. Next, fourth one, phi of t1 plus t2 is equal to phi of t1 into phi of t2. How it is? Just see here. Phi of t1 plus t2 equal to e power, this one it is in place of t, it is t1 plus t2. Plus substitute here. So e power 81 into e power 82. What is e power 81? Phi of t1. This one is phi of t2. That is right. And next, phi of t2 minus t1 into phi of t1 minus t2. That is equal to phi of t2 minus t0. These two cancelled out. How it is? Just see. So while taking this one, phi of t2 minus t1 into phi of t1 minus t0. That is equal to, again same, in place of t, substitute here e power a into t2 minus t1. Here e power a into t1 minus t. Just to separate all the terms, e power a t2. Okay, in this way also, or separate, otherwise directly. Combine e power a into t2 minus t1 plus t1 minus t. These two cancel. This is minus t1 plus t1, right? So you get here e power a into t2 minus t0. So what is the phi of t2 minus t0, right? So these are the important properties of state transition matrix. Okay. How to determine, how to compute the state transition matrix? We have different methods to find the state transition matrix. So first one, it is a power series method. Second one, Laplace transform method. and third one is Cayley-Hamilton method. We'll go in detail by taking with some examples. Take first one, power series method. It is like expansion of exponential function on e power at. You know already here, right? I plus at plus a square t square by 2 factorial plus a cube t cube by 3 factorial and so on. It is a power series, continuous expansion only. Okay. So second one, Laplace transform method. This one already we have discussed in the previous videos also. For finding the solution of state equation at that time also we found this one. Laplace inverse of Si minus A inverse. Right? And third one, it is a Cayley-Hamilton method. Okay, one by one we'll go in detail. Now we'll see first one with the example. Determine the matrix exponential, that is STM, and hence state transition matrix and homogeneous response to the initial conditions x1 of 0 equal to x2 of 0 equal to 3 of the system with state equations. Okay, here it is not one objective, we have many objectives here. So our part particularly only for that is to find the state transition matrix, and remaining parts also we'll see. Sometimes they can ask like this also. Okay, now this is the state equations given x dot equal to ax plus bu and same. Okay, here x1 dot x2 dot. Just see here minus 2x 2x1 plus 0 into h2 plus u. In the second, x2 dot equal to x1 minus x2 plus 0 into u. Right? So that is the expression given. So from this you can find out the matrix system matrix A minus 2 0 because x2 coefficient is 0 here. Here 1 minus 2, that is the matrix. If you want B, what you will get here? Here it is 1, second one is 0, 1 0. Okay. Now first one we want to find out matrix exponential and STM. What is STM? This one only. Phi of t equal to e power 8. That is equal to I identity matrix plus at plus a square t square by 2 factorial plus a cube 3 cube by 3 factorial and so on. A power k by k factorial and so on. It is a power series. We will take at least 3 terms. That's enough to find the STM. Identity matrix because it is a 2 by 2 matrix. We will take 1 0 0 1 plus A. What is A here? This is the A matrix. Substitute here into T plus A square. You know it is a into A. Find out that. So 4 0 minus 3 minus 1 into T square by 2 factorial. A cube. A square already we know into A. Just multiply this and this. We will get this one plus and so on. Just add these terms. 1 minus 2t plus 4t square by 2 minus 8 cube by 3 factorial. That is the first term. Similar way, we can find out 0 plus 0 plus 0 plus 0. Right? 0. Like this you can find out. This is actual. Right? So sometimes you can simplify. It is not that much easy. Okay, sometimes you will get direct expressions, sometimes you won't get direct expressions also. If you see here, it is a direct expression, continuation only. You can say e power minus 2t. What you will get? I plus minus, right? Here you are getting here. Minus 2t plus minus 2t square by 2 factorial plus minus 2 3 cube by 3 factorial and so on. Directly you will get here e power minus 2. Here also you will get e power minus t. This is 0, but here it is not that much easy. Okay, so that's why if you are finding up to this also, STM is correct. Okay, but sometimes if you want to find exact, if you are comparing with that, so at that time you have to simplify that. Otherwise, up to this solution it is fine. Now, so this value it is, if you are taking this minus, just you see here, this minus this, you will get the expression. That's why here e power minus t minus this, you will get the expressions. It is simple. So 1 minus 1 0 minus t, this one, right? What you will get here? This value minus t, minus of minus plus t, so that is a t. Here minus t cube by 3, here minus, what you will get here? This minus this, right? You will get minus 3 t square by 2 factorial. Okay, so in this way you can find out e power minus t minus this. This is phi of t. But homogeneous solution or homogeneous response to the initial condition here, that is nothing but, so homogeneous solution here, phi of t into x of 0. Already we found that. What is x of 0? 2, 3. It is a matrix, right? So first row is 2, second row is column matrix it is. So just already we know the values here, x1, x2. How to find out? Just substitute that value into this one, 2, 3. Just find out that you will get the expressions here. So 2 into e power minus tt, and here what you will get? This into 2 plus 3 into this, right? So 5 into e power minus t minus 2 into e power minus 2. Okay, so that is the homogeneous solution. If you are representing in vector form, x, that is nothing, x1 of t, x2 of t equal to 2 into e power minus t, and second value is 5 into e power minus t minus 2 into e power minus 2. This is the way we can find out state transition matrix by using power series method. Okay, second method by using Laplace transform. We will take one simple example here. Find the state transition matrix associated with the non-diagonalizable matrix. Okay, so directly they have given matrix A here. So you know how to find out Laplace inverse of, okay, Si minus A inverse, right? If you are finding e power at, that is Laplace inverse of this. So you know how to find out Si minus A. This is A, Si, S0, 0S. So S minus 1, minus 2, 0, here S minus 1 of inverse of this one. What you will get? It is a 2 by 2 only directly. Determinant S minus 1 whole square. So you can substitute here 1 over S minus 2, 2 over S minus 2, S minus 1 whole square, 1 over, because these two terms will cancel, because the determinant we are getting S minus 1 whole square, right? So this is the term. Apply Laplace inverse. You will get here, that is the STM, state transition matrix, e power at equal to e power at, that is e power t. A is here what? It's 1 over S minus 1. If it is S plus 1, e power minus t. Here it is S minus 1, e power t. Here 2 into, because it is a 1 over S minus 1 whole square, t into e power t. Here again it is e power t S0. So in this way you can find out the, which one? State transition matrix by using Laplace transform method. In the next video, I will explain about state transition matrix by Cayley-Hamilton method. Okay, thank you all.